Today we're going to keep going and look at some properties of logarithms. Yesterday you guys looked at what logarithms are. So today we're going to kind of see how they work. Now remember, logarithms are related to exponents. They're the opposite operation, the inverse operation. So we can use some of the properties of exponents to help us learn some of the properties of logs. This first example is kind of going back a couple chapters. If we have 3 squared times 3 to the 4th power, the base number is the same. We know that we add exponents in this case to figure out the answer. So we'd have 3 to the 2 plus 4 power, which is same as 3 to the 6th power. So multiplication turns into adding for the exponents. So if we're looking at logs, as you can see on your note sheet, pretty much the opposite is going to be true. If we have a log of two things being multiplied, it turns into addition of two separate log functions. So in this example problem over here, if we have log base 3 of 2 times 4, we can rewrite that as log base 3 of 2 plus, the multiplication over here turns to addition, log base 3 of 4. So you can split logs apart. If you got things being multiplied, you can split it apart into addition. And that's one of the properties we're going to use to simplify some of these logs. All right, so let's take a look at a few problems here. On number 1, example number 1, they want us to use the fact that log base 2 is about a half, and log base 4 of 3 is equal to about 0.79248 to approximate the value of log base 4 of 6. So when we're doing this, what we want to look at, what we're going to want to look at is how can we split log base 4 of 6 apart? Well, we know 6 is the same as 2 times 3. So now we got 6 being the same as the factors 2 times 3. Well, we can use log properties now to split this apart. This would be the same as log base 4 of 2 plus log base 4 of 3. So the log property allows us to take two logs being multiplied and change it into addition. Now using what they told us up here, we can approximate the value. So log base 4 of 2 is about 0.5. Log base 4 of 3, they tell us, is about 0.79248. Now we can add those together to get the approximate value, which is going to be about 1.29248. So it's using log properties. Let's take a look at another one. On the second example, they also want us to use log properties. So number 2 says, use the fact that log base 2 of 3 is equal to about 1.58 to approximate the value of log base 2 of 48. All right, so we're going to try and use these log properties. Now this one's a little bit different because they only gave us one approximation. They gave us log base 2 of 3 equals that. So what we're going to try to do is split log base 2 of 48 up into two separate factors. If we try to see how many times 3 goes into 48, since they are giving us here a value of 3, let's use our calculator to see what we get. If we go 48 divided by 3, we get 16. So we're going to split this up into log base 2 of 48. Another way to write 48 is 3 times 16. Now log property says if we're multiplying here, this is the same as log base 2 of 3 plus log base 2 of 16. Now log base 2 of 3, we know from this approximation they gave us, is going to be about equal to 1.5850 plus. Now this one we don't know the approximation. Log base 2 is 16. But remember, logs are the inverse of exponents. So let's think. We're doing log base 2 here. 2 and 16. Does 2 go into 16? Yeah. 2 goes into 16. In fact, it's a factor of 4. So if we do, another way to write log base 2 of 16 is to write log base 2 of 2 to the 4th power. 2 times 2 times 2 times 2 is the same as 16. Now, I won't expect you to know this right away doing logs, but what you can do then, if you get something like this, where the base right here matches the base of the exponent, they really just cancel each other out. So what you're left with is that the log base 2 of 2 to the 4th power just equals now the exponent of 4. So this is going to be about equal to 5.5850. So anytime you're doing log and the base of the log matches the base of the exponent, they cancel each other out. All right, these next problems are also going to be using log properties, except that they're a little bit different in the fact that you only have log. It's an equation one, that's a difference, and that you only have logs on one side. So remember, we before just took some multiplication, split it into addition. We can also do the opposite, and we can combine two logs being added with the same base into a single log. And that's what we're going to do on number 3 here. Notice that both of them are log base 4, and we're adding these two logs. So our first step, we're going to combine these together into a single logarithm. So if we combine them together, this would turn into a multiplication problem. Adding would turn into multiplying. So now we have log base 4 of these two things multiplied together, x times this other factor of x minus 6. Okay, we want to now solve this problem. We don't want to solve it though with logs. If we can get rid of the logs out of this problem, we can do it. So what we want to do now is change from log form into exponential form. So step 2, put this into exponential form. Remember exponential form from yesterday. What we're taking the log of here, x times x minus 6 is going to be equal to the base of the log, which is 4, to the exponent of what's on this side, which would be 2. All right, well, we can simplify that now. If we simplify a little bit here, we can distribute on the left side, x squared minus 6x. On the right side, we know 4 squared is the same as 16. This is a quadratic problem. Get everything to the same side. X squared minus 6x, subtract 16 is equal to 0. We can now solve that. What multiplies to negative 16 and adds to negative 6, negative 8 and 2. So this factors to x minus 8 times x plus 2. Setting them both equal to 0 and solving, we get x equals 8. Or x equals negative 2. Now, are both solutions? You want to plug them back in and check. If we plug back 8 in and check, it does work out. However, negative 2, the second answer does not work. And remember the reason why. Can we do logs of negatives? No, if we put negative 2 in here, we end up with log of a negative number. We know negatives and 0 are not in the domain of logs. So the other answer does not work. Only 8 is the answer. All right. Let's start another one here. Number 4, kind of a similar problem. They want us to solve this one. Again, first step we want to do, combine these multiple logs into one. Both of them are base 8. We're adding, so we know we can now change that into a multiplication problem. Log base 8 of x times x minus 12 would equal 2. Now our next step, change this into exponential form, and then we can keep solving. I want you to try that one for tomorrow. Start by changing to exponent form now, and then see if you can solve this one out. So it's kind of similar to the last one. Next step, change to exponent form, then see if we can keep solving. All right, let's look at another exponent property we know from a few chapters ago. If you're dividing where the base number is the same, what you do is you subtract the exponent. So this 3 to the 4th over 3 squared would be the same as 3 to the 4 minus 2 power, which is the same as 3 squared. So if you are dividing exponents, it changes to subtraction. The same is true with logs. If you're dividing logs, if we get the division of logs, it changes to subtraction of those same two logs. So in this example problem you have, if you got log base 3 of 4 divided by 2, another way to write that would be log base 3 of 4 minus log base 3 of 2. It's always the top one minus the bottom one. So we're going to use this to also solve some different log problems. On number 5 on the back, they want us to go through and try to simplify this logarithm problem. It says use the fact that log base 3 of 5 is about equal to that, and say log base 3 of 20 is equal to about that. Approximate the value of log base 3 of 4. Well, we got this 5 and 20. We know we could also write 4 as log base 3 of 20 divided by 5. 20 divided by 5 is the same as 4. Now, if it's a division problem like we have here, we know log, when we divide, is the same as subtracting these two logs. So we could write it as log base 3 of 20 minus log base 3 of 5. Using the approximations they gave us, now we could figure out the value. Log base 3 of 20 is equal to about 2.7268. Log base 3 of 5, they told us, is equal to about 1.4650. Subtracting, now we can get the approximate value. Subtract those out, and this is the approximate answer. So that's using properties of logs. All right, tomorrow we're going to look at one last log property in class, and that we can use to help us solve some of these problems.